2003. Oh, hi! I was just doing my daily workout. Do you want to join me? Here, have a go. Oh, what? What? It's too heavy for you? Oh, sorry. I just forgot how hardcore I am. Ah, check out these guns. I wonder how they work. Your bicep and your tricep are antagonistic muscles, which means they work together as one of them contracts, the other relaxes, and vice versa. Now, there are three different types of muscles. Cardiac muscles, which are the types you can find in your heart. Smooth muscles, for example, they control the diameter of your blood vessels. Both of them are involuntary muscle, which means you have no control over them, they just do whatever they like. Last of all, you have your skeletal muscles, which you do have control over, and the ones you use for running and walking. Your muscle fibers look a little bit like this, except with a little bit more detail into it, like the sacrolemma membrane, which covers the whole thing, and the T-tubules, which is like the infolding of the membrane, and the sarcoplasmic reticulum, which think of it as like underground channels that run all the way through close to the fibers. And there's also lots of mitochondria for ATP production that you'll be using during your muscle contraction. And going back to my fabulous model, myofibril is made up of smaller components of filaments, actin and myosin. The pink ones are actin and the red ones are myosin. There are three different bands, A, I, and H bands. H contains the M line and I contains the Z line, which is, it's fine. If I was part of a muscle fiber, I would love to be called after random letters of the alphabet. This is the formation of the fibers in the state of relaxation, and when you tense, these muscles contract and shortens like so. So now let's zoom in and see how that happens. Okay, remember that the pink one is actin and the red one is myosin, and there's two other proteins, a fibrous tropomyosin, it looks like a string twisted around the actin, and troponin, which is in green, because I don't know, green is just a great color for a troponin, I think. So tropomyosin blocks the active site of the actin from binding with the myosin head. Okay, so when you move, everything is being controlled by your brain, because your brain is like the president of your body or something, and it orders your body to do mostly everything. The brain transfers like its orders down to where the orders are supposed to be carried out through the nervous system. Don't worry if you don't understand the rest of this video, it's just fancy terms of saying the mailman came and gave the orders to the muscle department from the president, and they're like, "Alright, man." And in the neuromuscular junction, where the muscles and the nerves kind of meet up, what happens in the neuromuscular junction is that as action potential arises, calcium ions go in and binds with vesicles of neurotransmitters. They kind of kick out the vesicles so that the neurotransmitter is released into the synaptic cleft, and they diffuse and reach the other side and binds with the receptors on the sacrolemma, and this causes the depolarization of the membrane. Also down the T-tubules, and this causes calcium ions to be released out from the sarcoplasmic reticulum. Once Ca2+ ions is being released, they bind with troponin, and this causes the blocking molecule to kind of change shape, and the tropomyosin moves away from the active site so that now it's exposed to the myosin head, so that it can bind with it now. Okay, myosin head binds with it, it tilts down. This tilting of the head moves the actin to the middle of the sarcomere by about 10 nanometers, which is like 0.000000001 meters. That's really tiny. There's lots of fibers, which is a good thing, and lots of 10 nanometers added up together makes a significant amount of distance. Okay, so once they tilt, the ATP is then hydrolyzed in the myosin head, which provide enough energy to force the head to let go of the active site, and this kind of repeats again and again until the action potential stops. So that's it, really. So now I'm gonna get back to my working out, knowing that my actin and myosin is doing its job. Yeah, see ya.